This video is going to focus on solving algebraic expressions using both an area model and the standard algorithm. For this lesson in particular, you're going to need to solve using both strategies, an area model and the standard algorithm. In future lessons, you may choose whichever one you like best or which is most efficient. At some point, you'll transition to using the standard algorithm full time if you're not already as comfortable with that. Looking at this as an area model, you could think of building off of the first lesson, making an estimate, and how would you solve this? In yesterday's lesson, you could think of this as 35 31 times. And you could figure out 35 30 times very simply, and then just get it to one more group. Using an area model, we can build off of that and represent this by putting the 35 at the top The reason I represented it this way, it looks more like a rectangular model, but 30 is a really simple number for us to work with, and we can do 35 times 30, relatively simple in our heads without breaking it down. 35 times 3, 35, 70, 105. But we have to make it 10 times bigger because it's not 3, it's 30. 35 one time is 35. So all you need to do is now we figured out 35 30 times and one more time. So just add it up and we get 1,085. To solve this using the standard algorithm, start by multiplying the ones place, in whichever one you wrote at the bottom, by each of these first. 5, 3. Now, I'm going to multiply the 3 by both of those at the bottom. So it's that 3 is in my tens place, so I'm going to put a placeholder in. 15, 9, 10. 1,085. And we did it correctly, so both of these answers match. In the second example, now it doesn't work quite as well to do a similar model because if I broke 59 up, let's say, into 50 and 9, that doesn't really help me because I don't know how to do 87 times 50 in my head. So I wind up in the same problem. So my area model for this one is going to look more, I'm going to break it more into squares than I am going to keeping it as the rectangle. So as you can see, I broke the 87 up into 80 and 7, and I broke the 59 up into 50 and 9. So now all of these I can do in my head, and that's really the purpose of the area model. We should be able to use our understanding of base 10 and solve each one of these in our head. I know 8 times 5 is 40, but it's not 8 times 5, it's 80, so we have to make it 10 times bigger. And it's not 80 times 5, it's 80 times 50, so we have to make that another times bigger. 8 times 9 is 72. Make it 10 times bigger. That's 720. 7 times 5 is 35. 10 times bigger, 350. 7 times 9 is 63. Now, in this one, it gets a little bit trickier because now you have to add that up and make sure you line it up correctly. So 5,133. Using the standard algorithm, start with the ones, 63, 72. Multiply now by the tens, so we write our answer in the tens. 35, 43. Do 133, and they match up, so we can see that we did it correctly. This next problem, 3 digits times 2 digits, you're going to use the same process, and we're going to break both of them up into place value. So we're going to go a little longer this way. $437 by 48. 4 times 4 is 16, but it's 400, 100 times bigger, and it's 40, so 10 times bigger. 4 times 3 is 12, 10 times bigger for 30, another 10 times bigger for 40. 4 times 7 is 28, 10 times bigger. 4 times 8 is 32, make it 100 times bigger. 3 times 8 is 24, make it 10 times bigger. 7 times 8 is 56. Now we have to add all of that up. Six, 12, 17, 2, 4, 6, 8, 9, 6, 9, 10. $20,976. You can see how the addition gets a little bit trickier when you start doing it with 3 by 2s. You got to really make sure you line up the place values correctly. Know your math facts. 56, 24, 29, 32, 34, 28, 12, 14, 16, 17. $20,976, and these match, and we could see that we're correct. If they don't match, he made an error on one side or the other. You can see it now when we start getting 3 digits times 2 digits. This is probably more practical for us because it has less opportunity for error, and that's one thing we're looking for. We don't want a large opportunity for error. Lining this up and then adding it correctly is probably a better chance you're going to make a mistake somewhere. The last problem we're going to look at is just finding the relationships, and these shouldn't be too difficult, but you have to be able to make sure you interpret words correctly. Betty saves $161 a month. She saves $141 less each month than Jack. So if you're going to put Betty next to Jack, who should be bigger, Betty or Jack? That's the first thing I'm going to think, well, Jack should be bigger because Betty is $141 less than Jack. So Jack must be $141 more than Betty. So if Betty is 161 and she's 141 less each month than Jack, then Jack's going to be 141 more. If Betty saves $161 a month and she's 141 less than Jack, then Jack saves 302. So how much will he save in 2 years? If this is each month, so that's in 1 month now. And if it's asking 2 years, you have to know 12 months is 1 year. So we could find out 1 year, or we could go all the way to 24. So you have to realize whatever he does in 1 month, we're going to have to get 24 times that, or you're going to have to add this 24 times. I recommend using multiplication. So you have to look at how these words in the sentence play out. He's going to make $7,248 in 2 years doing this job. So just read carefully and make sure you're reading the units correctly to figure out what you need to multiply by.